Hi guys, Assalamu alaikum. This is Arif. In this video, I am going to show you how we can compile and run simulations of RTL codes on Questa by Intel. And in order to do that, first we have to go to here home, and then you have to open Questa, and out of these options which we have installed of this software, I am going to click on this Questa, and this is going to open up our Questa where we can run our RTL codes. So this is their GUI after running of that TCL script which we saw in the command window. And first I am going to show you how we can run a Verilog code in this video on Questa, and then I am going to show you how we can run a VHDL code on Questa. So first of all, let me show you how we can run a Verilog code. So this is file new and project we are going to select, and on the project name we can give our project name as project SystemVerilog. And in order to save this project, we can actually create a new folder inside this Intel FPGA location, new folder, and we can name it as project SystemVerilog. So this is the project which I have created, and this project we can select folder here. So now we have given the directory for our project, and rest of the things would stay same. Click OK. Now we have to create a new file for our project. So click create a new file. Since we are going to first do our SystemVerilog program, so select SystemVerilog here. File name we can give as our program SystemVerilog, and we can say OK. And now we can create a new file as well for the test bench. So for the test bench again, we are going to select here SystemVerilog, and then we can say file name we can give as test. So type is SystemVerilog and file name is test. This is our, now we can close this window, click close, and now we can go and open this file. So since somehow this file is showing as a notepad file, so I can type here in order to open this file properly. So edit program underscore sv dot sv. So this is going to open this file, and now let's expand this like this, and then we can open our again the second file as well, is test.sv. So we have opened our both files. So first file in which we are going to write our program. So the program I can just copy paste. So this is a simple program because I am going to show you how you can start running your first program on Questa. So I am going to just copy paste it. Since we are going to use this edit program command in the transcript window, the file is going to be read only, so we can make it by clicking here. We can remove that restriction read only. Now we can paste our program. So this is our program. We can save this file from here. And now we are going to do is we are going to try and compile this file. So we have compiled our file. Compile is successful here in the transcript window we can see. Now we are going to give a test bench to our file so that program so that we can actually test this program as well. So this is the test.sv. We are going to click here and we are going to, this is again read only, so we are going to convert it into a write only by clicking here, and then we can paste here. So remember, right click, and if the file is read only, we can click here read only. Now we can edit this and then we can save it. So after saving, we are going to see here a question mark because the question mark is telling us the file is not compiled yet. So right click, compile selected. So now again the compile was successful. You can see the transcript window. There is a green arrow here, green arrow here. So the compiles have completed. Now we are going to run the simulation. We can go to here. This is the project window right now where the two files are saved. Right next to it is the library window. We can go here, and here this is the work, and in the work on the test bench file which has name test. So we are going to click on this, right click here, and we can see the first option simulate. So we are going to click this, and now we are going to see here the simulation window has opened. This wave window we are going to click here. So after clicking on the wave window, these are the other two files which we have of our system Verilog program. So after clicking on the wave window, we are going to add these two signals, our input and the output, so that we can see their waves as well. So we are going to click on this, and then we are going to press the control key on our laptop, and then we are going to select this one as well so that we can select both of these signals and we can just then drag those here. And once we are going to drag those here, now our both signals input and output have added to our wave window. Now we have to run this simulations from here, run. So after running this, since the wave is a bit short, so we can just expand this wave. Now we can see a bit. So our program has, once the input is 0, output is 1. Once the input is 1, output is 0. So this is the way we can simulate it, and after that, once we are going to stop simulation, we can click here simulate, and then we can end this simulation. Okay, but before ending this simulation, I am going to show you one more thing, that how we can check actually the schematic of our program which we are running here, which we have created in our SystemVerilog. So in order to do that, in the transcript window, we have to type this vsim, and then we can say this dash debug db. After writing this, we are going to give a space, and then we are going to give here the name of our test bench and the name of our test bench module. The Testbench module has name test. So test is our Testbench module name, and we are going to type this here. So vsim dash debug test, and then we are going to press enter. So if we don't see any error here, we can see here some messages which are light blue messages. There is no red messages here in the transcript window. That means everything looks fine. So after that, what we are going to do it, we are going to go to this view, and then we are going to click here schematic. So after that, we are going to see this schematic window. We can see here schematic window. So we can click here, and then we are going to see here a small box. Click on this box, and then we are going to see our schematic. This is our unit under test. So let's click on this, double click, and then we are going to actually is actually at the corner, so we can just place it here, and then we can just make it larger a bit. So this is our inverter which we created, right? And this, so if we want to see the whole scene again, we can go here. This is our outside look of our schematic. This is our UUT inside it. By clicking here, this instance window, we can see. So we have seen both. Now we can stop simulation and simulation. So now end simulation is going to take us back to again this library window, and then we can click on the project window. So this is our module, and this we have declared in this file, in a SystemVerilog file. This is the SystemVerilog program of an inverter which has input, output, and after that we are going to use this line assign, and we are going to say invert this input and assign it to output and end module. And after that we can see our test batch program. Test batch program has this module test name which we typed here in this transcript window. Once we are going to see that schematic of our programs. So whatever name we are giving here, not the file name and test file name here, and this module name can be same as well and can be different as well. In this case, these are same. So remember, once I was using this command in our transcript window, vsim and then dash debug db. So once I was typing the test word, I was typing this test word, which was the module name inside our test bench file, not this test bench file's name. So remember this, these two can be different as well. So program is going to get compiled, and we can run simulations as well, but these can be different as well, these can be same as well. Same way, here our module name is inverter, but here the file name is different. So they can be similar names, but they can be different names as well. Nothing would change or nothing wrong with our program. So after defining this module test, we are giving here, so the input would be always reg, output would be in the test bench, output would be always wire, and after that we are giving here the instance of our inverter module. So this is the same module inverter, it has input output, and this is the way we are going to assign input inside here, output here. And after that we are going to use this initial block, and we are going to say begin at 0 time. We are saying put 0 inside input, and after 10 nanoseconds we are saying put 1 inside our input, and then we saw the corresponding outputs as well. And after this initial block is going to end like this, and after that we are going to say end module. So this is a very simple program which we used to run and compile inside the Questa sim. So this is the way we can compile and do simulations inside Questa sim for a system Verilog program. Now I am going to show you how we can actually compile and simulate a VHDL program inside Questa sim, and we are going to go again here to file, and after that we can say yes. So once I was here, so I was clicking the file, I was not able to see a option which I wanted to see. So I once I am clicking here inside this project window. So after that, once I am clicking here file, I see close project option. So we have to select this close project option so that we can close this system Verilog project, right? And after this, we are going to see this message. We can say yes, and then our project is closed. Now I am going to create a new project which is going to be a VHDL program. So we are going to go to here file, new project, and here we can give our project name again VHDL we can say, and then we can go to this browse, and we can go outside of our this directory or folder, and we are right now inside this folder. Here we can again say, we can actually select here new folder, and then we can say same way we can say project underscore VHDL, and then we can select this project. First we can create this project, and after that we can say project VHDL. We clicked here, and we can say select this folder so that everything gets saved for this particular project inside one folder, not anywhere else. So select folder. After that we are going to click OK, and now we see again this window, and we are going to say create new file, and this file we are going to say file name program underscore VHDL, and here the type is VHDL already, so we are not going to change this. We are going to say OK, and then we are going to create another file for our test bench, and we are going to say test is our file name, type is again VHDL, and we are going to say OK. So now we can close this window. So now this time the project window is not showing us the files as of notepad type, and we are going to directly click here. So actually let's close these two Verilog files. First close these files. We have closed these, and now we are going to directly click here, double click here, and window got opened, and now double click here. So this is actually the way. I don't know why right now this software for the Verilog extension it is showing the files as notepad files, but if you see that case you can always type here the edit command the way I typed, otherwise you can double click here. So let's go to our program VHDL file, and then I am going to again just copy paste this written code which I have. So this is our VHDL code, simple code for an inverter, and we are going to say save. We are going to click save, and then after that we are seeing here question mark. Let's compile this, compile selected. So compile was successful, and now we are going to again come here, and we are going to just copy paste our test bench program as well. So we can say paste here. And remember, this time we didn't need to do this read only kind of a thing because the file is right now automatically in the write mode. So we have to just save here, and after the save we have to compile this file to compile selected. So both files got compiled, and now what we can do is we can go to this library window. We are going to see here again this work, and then we are going to click, this is our test bench file, so we are going to click on this, right click, simulate. Very simple programs I am showing you so that your focus should be on how to compile and simulate rather than how the VHDL or Verilog codes are written. So once the simulation windows are open, we have to select the signal by clicking on this, then control key, and then we have selected both the signals, input and output. We drag those to here, then we can start this running the simulation so we can see our waves. Let's make those waves a bit bigger. So this is the once the signal is 0, output is 1. Once the input is 1, output is 0. This is the way the inverter works. Again, I am going to show you how we can run the schematic this time for our VHDL inverter. So we are typing here vsim command again, debug db, and then we are going to write the module name of our test bench, not the file name of our test bench, but the module name. So that is test. So press enter. Once we are going to see these messages, blue messages inside the window, transcript window, that means everything looks fine, and we can just go here to our view window, view tab, and open the schematic window. So let's see how the schematic of our inverter looks in VIDR. After that, we see the schematic window, click here, click on this box, and we see this. And let me just show you this one. So this is the way we are going to see the schematic of our VHDL code. A little bit different, but similar as well. We can see inside this inverter, you see, schematic. Inputs and outputs are also showing. This is the main schematic, and here we can see the test bench schematic. So after this, what we can do is we can just go to this simulation tab and simulation button, and we have closed our simulation because everything compile and simulation was good. So go to this project window again. These green marks are going to show that compile was successful, otherwise there would be red crosses here if the compile won't be successful. And now I am going to show you this entity of our inverter. This is the way we are going to give this library, and then we are going to say this entity would be inverter. It has two inputs, and this is the architecture of the inverter, and we are going to say inside this begin block that invert the input and give it to the output. And this is our simple inverter program, just a few lines. And after that test bench, we are going to say again this, we are going to first declare this entity with the name. This is the way we are going to give our architecture. We are going to use this inverter which we defined here. So just copy paste this whole block here, copy, and then paste it here. And one thing you have to do is you have to just change this entity with the component, and here also component we have to write. And after that we are going to say signal. We are going to define input and output, just like in Verilog we defined reg and wire, and in this case VHDL we are going to say signal, std logic, and then we are going to say this begin. And then we are going to say we are going to use this instance of our entity which we defined here. We are going to say inverter is, we are going to assign its input and output. This is the way. Signal we are going to assign to input I, and output O we are going to assign to the output. And this is the way we are going to start then the process block. And inside this process block we are going to say give, first we are going to give 0 to the input I, and then and after that 10 nanoseconds we are going to say give the input value 1, and then we are going to use this wait statement so that our process statement just does not keep running. And after that we are going to end this process block, and then after that we are going to end this architecture block as well. Architecture, this we are going to say behavior. So this is just our complete test bench code. So thank you guys. I hope you guys have learned how to compile and run the simulations inside Questa sim for your Verilog and VHDL programs. Have fun.